Good morning. Today we are going to see part 3 that is related with welded plate girder. We have seen steps of plate girder. We are first with given data. Then second step we have shear force and bending moment. Then third we have dimensions of web plate. Then fourth dimensions of flange plate. Then moment capacity. Then we have shear capacity. Then after shear capacity, we are with connection between flange and web. Now we are with step 8, curtailment of flange plate. Already I mentioned, go to these videos because that will gives you different clause numbers. I am not going to mention here clause numbers. Otherwise, that will not be a revision lecture, that will be detailed lecture. Now this is our problem. So now we are with step number 8, curtailment of flange plate. Step 8, we have curtailment of flange plate. Curtailment of flange plate. Now, how much we can curtail this flange plate? So we have to go to table 2. And from table 2, we are in position to know how much we can curtail. And that is B upon TF. So we have B upon TF, and that is 13.6 for semi-compact. This is for welded section. And now B in this case, we have 400 minus 10. Thickness we have, sorry, this is not TF, B by 2 actually. Sorry, BF by 2. So we have this as BF by 2 upon TF. And now this TF we are going to say as TF minimum allowed. And then we have this will be upon 2 into 13.6. And this will give us TF minimum. And if you calculate this, then we have TF minimum below which we cannot go. That is 14.34 millimeter. And therefore, we will curtail flange plates on both sides, flange plates from 32 millimeter to 16 millimeter, from 32 millimeter to 16 millimeters. So now we have, if we will go to the diagram, sorry. So in this diagram actually, now our flange plate becomes 32 millimeters. So we have this as 16 now. Then we have, this will be as it is 10 millimeters. And then again we have this as 16. This is 1300 and this is 10 millimeters. So now we have to find the value of ZE. And this I will say as I by Y. Now value of I we have again 400. This is again 400. So we are going to consider first whole part as I already explained it. So this is 400 into 1332. So 1332 cube upon 12. So 1332 we have from top to bottom, 1332. Minus, so this we have to subtract 400 minus 10. So we have 390 into 1300 cube by 12. This is I. and divided by y. So we have from center. So we have this as 650 and plus 16. So it will go 666. And we will get value of ZE that is equal to. Actually, I have not calculated value of ZE. I have directly calculated MD. And therefore, we have MD now. ZEFY upon gamma MO. Now try to understand this. We have MD as beta B ZPFY upon gamma MO. Now as it is semi-compact, so we have beta B is equal to ZE upon ZP. And if we will put it ZE upon ZP into ZP into Fy upon gamma MO, then this ZP gets cancelled. We have ZE Fy upon gamma MO. And then we have ZE value, which we have mentioned above, that is 400 into 1332 cube by 12 minus 390 into 1300 cube by 12 whole divided by 666 into Fy we have 250 and gamma MO 1.1. And from this we will get value of MD that is equal to 2516 kilonewton into 10 raised to 6 Newton millimeter, which is equal to 2516 kilonewton meter. Now we are interested where we have this value of bending moment. So now I will just rub this part. Now we will find the point where our bending moment is 2516 kilonewton meter. Now we do not know where it will lies. Let us we will say it is in first 7 meter. So we have this value, we know 620. So let us we will consider somewhere here we have this value as bending moment. And then we will say bending moment equal to MD equal to 2516 equal to 620x minus this value we have 40 kilonewton per meter, so minus 40 into x square by 2, and from this we will get 20x square minus 620x, and that is plus 2516 equal to 0, and we will get x that is equal to x we have 4.8 meters. So we have value of x 4.8 meters. The diagram I have plotted in thumbnail, you can see over there. So we can write it, therefore, curtain plate at 4.8 meters from both ends. Curtain plate up to 4.8 meter from both ends. This is theoretical point of cutoff. We have to find it. And then if you will see the diagram, if I will draw this diagram, that is of one side, then we are going to be likewise. So we have this value, we have this thickness. This is 16. And after this, it will go 32. But we have slope that is 1 in pi over there. Then it will be 32 afterwards. Then it will be 32. So here we have this value that is 32 millimeters. And here this value we have 16 millimeters. And distance we are going to say till this, we have this value that is 4.8 meter. I have shown it in thumbnail, you can see it, you will get it. So this is step number 8, which is curtailment. Now we have step number 9, design of vertical stiffness. So step 9, design of vertical stiffness. I already mentioned, I am not going to mention all clauses and everything over here. You have to go to that videos which I have shown, that is 3456 from steel structure playlist. Now we have value of C by D, already we have calculated 1.3, and this value is less than root 2. Root 2 we have 1.41, and therefore we have to take value of Iz. If C by D greater than root 2, we have another value of Iz, and for less than we have this value 1.5 d cube t cube upon c square. And we have to put value 1.5 into 1300 cube into 10 cube upon 1600 square. And we will have this value 1.29 into 10 raised to 6 millimeter to the power 4. And now we have to provide the stiffener. Vertical stiffeners we are going to provide alternately. Now this is my web. And let us we have stiffeners, we have like this. Alternately we are saying we have one will be here, another will be here. Its sectional elevation I have shown in thumbnail. And this distance you have 1600. Now let us, we will consider this value 10 TQ. We can consider up to 14, up to 20 we can consider, but effective we have 14 TQ. So let us, we will consider it as 10 TQ. And the thickness we have, that is TQ. And then we have this value, that is, now we have moment of inertia of this stiffener, and that moment of inertia we have to take about cent, because we have alternate. Sorry, we have to take at face. If we have symmetrical, then we have to take that is at center. Now as it is alternately, then we have to take at face of this web. And then we have this value BD cube by 12. TQ into D, we have 10 T cube divided by 12 plus A into H square. Area we have TQ into 10 TQ multiply by AH square. So we have to take value from center, which will be 5 TQ, which is H. So into 5 TQ whole square, which is equal to 1.29 into 10 raised to 6. And if you will solve this, then we have this as 1000 upon 12 TQ to the power 4 plus 250 TQ to the power 4. Because this is 525 into 10 250, which is 1.29 into 10 raised to 6. And then if you solve this, we will get TQ value 7.88 millimeter. And then we have BQ, which is 10 TQ. This actually we have BQ. And then we have BQ is equal to 10 TQ. That is 10 into 7.88. This goes to 78.8. And therefore provide vertical stiffness. Provide vertical stiffener. Vertical stiffness. 10, we have taken this as 8 millimeter, because 7.88 we have, so 8 millimeter by 80 millimeter alternately at 1600 mm center to center. as shown in figure. You have to draw this figure by pencil properly. So don't think sir is not drawing properly, so we need not require to draw it properly, because I am on notepad and therefore it becomes difficult. So we have next step, that is step 10, design of bearing stiffener. So I will say design of end bearing stiffener. End bearing means for reaction and bearing stiffener means for concentrated load. Now we have this value FPD. I already mentioned. I am not going to mention clauses, otherwise again these lectures will be lengthy. AQ into FYD divided by 0.8 into gamma mu, and this is equal to R. And now if we will find AQ, then we have value of R 620 into 10 raised to 3 into 0.8, gamma MO 1.1, and FYD we have 250. And from this we will get area 2182.4 millimeters square. Now we have AQ into TQ. We have AQ is equal to BQ into TQ, and that is equal to 2 into BQ. We are going to assume as 10 TQ, same as in case of vertical stiffeners, and that is equal to 2182.4. Now, why we are considering these two? Because for the vertical stiffeners, we are going to provide alternately, but these end bearing stiffeners, you have always symmetrical with center. So we are going to provide with sufficient end distance. We have this symmetry. End bearing stiffener or bearing stiffener, these are always symmetrical. And therefore we have taken twice, because we have this as TQ and again this as 10 TQ. Generally for stiffener, TQ is considered. And from this we will get value of TQ that is equal to 10.45 millimeter. And therefore 10 TQ we will get, which is BQ, that is 10 TQ, 10 into 104.45 millimeters. And we will get it as 104.45 millimeters. Sorry, 10 into 10.45. 10.45. And we will get it as 104.5 millimeters. And therefore provide end bearing stiffeners. Provide end bearing stiffener. End bearing stiffener as 12 millimeter by 110 millimeters. And now we have to check its strength. And then we have, as already I mentioned, so we have area of this stiffener. So we are going to consider 20 TW. As it is at the end, so we are only on one side. If we have intermediate or vertical stiffener, and in case of your bearing stiffeners, which is for concentrated load, we have 20 TW on both sides. So we have this 20 TW, means we have this distance as 200 millimeters. Now this distance we have 110 millimeters. And this is TQ, we have 12 millimeter. And therefore, we have to go to PD, we have to check its compressive strength. So we will first calculate value of I, and that we have 2 times BD cube by 12. 12 into 110 cube by 12 plus A into H square. Already I mentioned. Now we have to take moment that is at center. So we have 110 by 2 plus 12 by 2 and whole square. because we have to find here, this is 10, sorry, not 12. This is 10 millimeter thickness. That is of web until center of this. So 5 plus 55, it goes to 60 square, and multiplied plus, sorry, this is of stiffness plus of this web. So we have to consider 10 we have B and D cube, sorry, B we have 200 and D we have 10. So 200 into 10 cube by 12. So this is B and this is D, because we are going to find out at center. So this is cutting your 10 millimeter. And from this we will get value of I 12.18 into 10 raised to 6 millimeter to the power 4. Now knowing value of I, we can find value of R. So we have value of R is equal to under root of I by A. And I we have 12.18 into 10 raised to 6. And A we have 4640. We have already calculated A value. No, we have not calculated A. So A we have actually, I will calculate over here. So A we have this total area, this two stiffness and this web. So we have 2 times 12 into 110 plus we have 200, 2 into plus 20 in 200 into 10. And then this comes 4640 millimeter square. This 200 and this thickness is 10, and this 2 times 12 into 110. And then we will substitute over here. We will get value of R, and that is equal to 51.23 millimeters. And then we have KL upon R. So we have this as depth, and this is K is 0.7 into L we have 1300 and R we have 51.23, and this comes 17.76. As it is plate, and therefore we have buckling class C, and therefore we have to use table 9C, and in table 9C we have KL upon R 10, and then this is 20, and then FCD value we have 227, 224. And then therefore we will get FCD 227 minus 227 minus 224 upon 10, that is 20 minus 10 multiplied by 17.76 minus 10, and we will get this value 224.67 Newton per mm square. And from this we will get PD is equal to AE into FCD. AE we have 4640, FCD 224.67. So we have this value 1042.47, 10 raised to 3 newtons, 1042.47 kilonewtons greater than 620 kilonewton, therefore okay. So provide this. And then we have last step of this, that is connection between stiffeners and web. Step 11. Connection between stiffeners and web. Stiffeners and web. In gantry girder, actually, we have to go last step biaxial check that I have not taken. You have to take it actually. Q is equal to TW square upon 5BS. We have TW 10 square upon 5 into BS. Now we are considering vertical stiffener because we have then Q will be more in that case. Therefore, we have this value 0.25 kilonewton per meter given in IS code. I already mentioned. You have to go to that video and see all clauses. And then we have strength of weld equal to shear force. And you can see thumbnail. I have clearly shown all values over there. So we have this value that is, now I will directly mention in last we have seen this root 3 into 1.25 into 0.707. We will assume size of weld 6. Length of weld we are assuming 100 and that is equal to 250 into P. And from this, we will get value of P 321.23 millimeters. And then we can write, therefore, provide 6 millimeter weld of length 100 millimeter at 320 millimeter center to center. And this is all about diagram we have in thumbnail. So this all about your plate girder. And then we will see in next video, that is unit number 3 problems. So now we will stop here only.